The natural numbers are what I like to call our counting numbers. What do I mean by that? Well, everybody count with me. Ready? Go. 1, 2, 3. Where did we start? 1. What's the real first number? 0. So natural numbers are our counting numbers. It is 1, 2, 3, and so on up to what? Where do our numbers end? Infinity. Everybody cool? Easy peasy, right? I mean, you guys, I'm sure when you were kids, at least at one point, you tried to see how far you could count. Yeah. Some of you must have done that. I got to like 2000 and something, and I was like, this is stupid. And I stopped. I'm sure there are people out there that are obsessive compulsives that have counted to the millions, but not me. I recognize that, around 2000, okay, I can count. Anybody want to share how far they went before they gave up? 10? Well, the funny thing is, Sammy, is that's all you need to do, right? If you can count, not even to 10, technically to 9, you can count every single number until infinity, can't you? Because that's how our number system works, thankfully. There are number systems in the world that don't work that way. For example, the Incan number system in South America, the Incans, the guys that built Machu Picchu and all that stuff, they counted not in base 10, like we do, 10. Why do we count in 10? We have 10 fingers. Well, if we're lucky, we have 10 fingers. People are missing some. If you have 10 fingers, by the way, you have more than the average number of fingers. You get it? If you have 10 fingers, you have more than the average number of fingers. Do you understand why? No. Okay. Everybody in this room has 10 fingers, right? We all do, right? I want to be careful here. All of you have all your fingers, yeah? I don't want to hurt a feeling like somebody's lost half a pinky and they're like, you bastard. We all have all our fingers, yeah? Okay, everybody with me? Okay. So right now, there's 31 of us in this room, right? So if we count all our fingers, that's 310 fingers, yeah? Divide by 31, and that's 10 finger average each. Everybody understands? Well, what if my friend David Hull comes into the room who only has 9 fingers? He's missing a thumb. So now we have 319 fingers in the room and 32 people. 319 divided by 32 is not 10 anymore, is it? So anybody with 10 fingers has more than the average number of fingers. Crazy, hey? Yeah, that's one of my favorite math things, but I don't usually use fingers. We just happen to be talking about fingers and counting right now. Usually I say legs. If you have 2 legs, you're a freak because you have more than the average number of legs. Because some people only have 1 leg and some people have no legs. So the average number of legs on a human being on the earth is less than 2. But we all have 2 legs, so we all have more than the average amount of legs. Crazy, hey? I know, right? Math is fun. Anyway, why did this all start? What were we talking about?
But again, some people have extra fingers.
Yeah, some people have extra fingers too. My buddy's kid was born with an extra thumb, and I was really, really tight with him. And an extra thumb is no big deal, right? Like, it's not like he's disabled or anything. He's just got an extra thumb. So I went out and I bought a pair of baby mittens for him, but I bought 2 pairs and I cut the thumb off of one and I sewed it on. So it had 2 thumbs on the right hand and 1 on the left. He thought it was funny. His wife didn't talk to me for a long time. That's okay. She was a horrible person. And we were like 20, so I wouldn't do something so insensitive now. But at 20, right? I mean, come on. That's barely older than you guys. And you all laughed that I gave him an extra thumb mitten, right? So you're all with me. It was funny. It was a baby, right? No, they cut the finger off. The baby's fine. Yeah, they amputated it when it was just little. It's no big deal. They cut other parts off of young little boys that is much more of a big deal than cutting off an extra thumb.
Koalas have 2 thumbs.
Koalas have 2 thumbs?
Mm-hmm.
I did not know that.
Yeah.
I did know koalas weren't bears, but I did not know they had 2
They have
thumbs.
3 fingers and 2 thumbs.
3 fingers and 2 thumbs. Well, then they're going to take over the world. One of my cats has a thumb. It's got an opposable thumb. It can do stuff with it. It's really going to take over the world. Well, no, it's about to die. It's getting old. Why? Fingers! Right! Different number systems. In South America, the Incan people... that's where I stopped. Because we got talking about extra average fingers. Their number system was based on 20. Does anybody want to guess why? Toes. Yeah, because they were running around barefoot because it's warm there. And this was the number for 20. Want to know why? Because it's a person. 1, 2, 3, 4. With his feet. That was how they counted 20. I know, right? Cool, huh? You guys don't think it's cool, but I don't care because you're stuck here listening to me and you have to hear what I have to say. Even though you don't think it's cool, if I think it's cool, you have to hear it. By the way, if you have 2 ears, you have more than the average number of ears of human beings. Everyone's good with natural numbers? Okay, next. Whole numbers. Whole numbers are the natural numbers plus 0. So it is 0. 1, 2, 3, ... Mrs. Bag Crumble, up to infinity. Everybody cool? Everybody good? Okay. I don't have a whole story about whole numbers now. I did all my story time with natural numbers. And finally, integers. And integers, what are integers? They're whole numbers, all the whole numbers, plus negatives. So it is negative infinity, ... negative 3, negative 2, negative 1, 0, 1, 2, 3, ... infinity. Is everybody good with that? Okay, now, what do you notice is missing from all 3 of these that we use all the time? Decimals. And decimals' ugly cousin, fractions. Okay? That's what's missing here. All right? So, all of these guys, no decimals, no fractions. I feel sorry for fractions. No one ever wants to take them to the prom. Everybody good? Yeah? If you're lying, you're dying. Okay. Now, you guys aren't stupid. You're aware that decimals and fractions exist, yeah? All right. Decimals and fractions live in their own sort of subset, if you will, of the number system. They are rational numbers, which you have heard this term before. A rational number is any fraction. A fraction is automatically a rational number if any fraction that has this form. And the form is this. A, any number, over B, any number. So, but there's some rules. A and B are integers. So they have to be an integer. You can't have a decimal on top of a decimal. They have to be integers. And B can't equal what? Kaylee. B cannot... Oh, the son of a... $2,500. Works like a dream. You know what works and didn't cost $2,500? The computer I used all last year. Oh, the board too. Okay. And B cannot equal 0. And you guys know that, yeah? You can't divide by 0 because it doesn't exist. If you try it on your calculator, you get error. You can't do it. And it makes sense, right? Because if you were to go to your calculator and do 1 divided by 0.0000000000001, you would get a billion, right? The closer you get to 0, the bigger the number is if you try to divide by it. But eventually, if you divide by 0, you can't do it. Everybody cool with that? So that is one version of rational numbers. The other thing that makes a rational number, and I'm going to change color to write it because it's a different definition, is any decimal that ends or repeats. Okay? Everybody cool? Well, it's a typhoon, dude. A typhoon is a hurricane in the Pacific. A hurricane is a hurricane in the Atlantic. That's why it's called a hurricane. What? No, hurricane is the word for a hurricane in the Atlantic. Because we call them, because they are so common in the Atlantic Ocean up the American seaboard, they got the name hurricane. But on our coast, they spin the other way, so they're called a typhoon. Relax. It's just rain.
No, I should have brought my umbrella.
You should have brought your umbrella, but you're a teenager, so no, you're going to walk home in a hoodie, you're going to get soaked, and you're going to be like, I'm cold and wet. And, oh, God. I mean, I was the same way when I was your guys' age. You know, the one day a year it snowed in Vancouver, I'd still wear a t-shirt and shorts to school and then complain about how cold I was. When you guys graduate, you get to wear jackets, gloves, hats. You can do all that and nobody will care because you don't have to worry about looking cool. You get to be warm and dry. Nothing, you don't have to care. Okay, that's the number one thing about graduating. Well, that and you can run with scissors. And eat dessert for dinner if you want. Actually, there's a lot of stuff. But those three are big ones. You can dress for the weather, you can run with scissors, and you can eat dessert for dinner. Well, aren't you advanced? All right, so I want to call your attention to something. Okay. Everybody, with your calculator, 35 divided by 53. Is that a rational number? Yes or no? Why, Caitlin? Why, Abresia? Because it's a number that's an integer over another number that's an integer, and the denominator is not 0. Is everybody cool with that? That is a rational number. End of discussion. Okay? But if you actually punch that into your calculator, what happens? 35 divided by 53. Does that look like it is repeating or ending? Yes or no? It ends because the screen ends. Everyone agree? So if you punch that into your calculator, does it look like a rational number? No, you would say no because it doesn't repeat or end, right? But because it's a fraction, it is a rational number. Is everybody cool with that? If your calculator screen went all the way over to Caitlin, you might find a pattern that starts repeating. Do you understand what I'm saying? Everybody with me? Is everybody with me on that? It appears irrational as a decimal, but it is rational because it's a fraction. Everybody good? Cool? Okay. So, A, yes, it's rational. But B, as a decimal, it appears. It appears not. The appears is key. Does everybody understand? Okay, now, there are numbers in our system that will never repeat, and even if your calculator screen went all the way around the world, even if your calculator screen went all the way to Pluto, even if your calculator screen went all the way to the end of even if your calculator screen existed in every possible incarnation of the multiverse, the number would never repeat or end. Those numbers exist too. You guys know of one famous one. What is it? Pi. Irrational numbers, duh. Any number that doesn't fit a bow. Oh, son of a!
Oh, money well spent.
We are. That's why I'm maintaining such a calm and cool outward appearance. Any number that doesn't fit the above definitions. Oh my God. Okay, talk amongst yourselves because I'm restarting.